Hello and welcome back. We're going to talk about atoms and ions. When a student first starts general chemistry, they sometimes make the assumption and mistake that everything must have equal numbers of protons and electrons. This is true of atoms or elements, which are neutral, but not ions, which are technically charged atoms. So in this video, you'll learn about that. Atoms are neutral. Okay, this means they contain equal parts of the positive and negative parts of the atom, and they have equal numbers of protons and electrons. It's critical in this video to remember protons have a charge of +1, each electron has a charge of -1, and we're going to use this charge formula throughout. The charge of a creature, or an atom or an ion, is equal to the number of protons minus the number of electrons. So let's count the protons up. There's 2 protons. Let's count the electrons. There's 2 blue negatively charged electrons in this model. So 2 minus 2 is equal to 0. So this is a neutral atom with a charge of 0. All elements are neutral, okay? So let's work through a couple of examples. How many protons and electrons are in an atom of oxygen? So first, you want to grab your periodic table and find oxygen on the periodic table, all right? So oxygen is element number 8, and remember the atomic number is equal to 8, so that's how many protons this guy has. Now since we're talking about an atom or an element, it also must contain 8 electrons. If we use the charge formula now to compute the charge, we're going to have the charge is equal to 8 minus 8, which is just 0. We call that neutral. Okay, so this is a neutral atom of oxygen. How about lithium? Now for lithium, you once again want to look around for that on your periodic table. You'll find that up on the upper left-hand corner. Lithium is element number 3, okay? So because its atomic number is 3, it contains 3 protons. And since it's an atom, right, in the word problem we have this keyword atom, it also contains 3 electrons. If we compute the charge, we of course can see that 3 minus 3 is equal to 0. It's neutral, okay? So all of these guys on your periodic table are neutral. They contain equal numbers of protons and electrons. Their charge is 0. Ions, no. Ions have unequal amounts of protons and electrons, okay? We have 2 vocabulary words to describe these. We have cations, which have a net positive charge, and we have anions, which have a net negative charge, okay? Cations have a net positive charge because there are more protons than electrons, and anions are negatively charged because they have more electrons than protons, okay? So here's the model. Let's focus in on this here a little bit, and we can see 1, 2, 3 protons, okay? And we know that this must be referring to atomic number 3 because lithium has 3 protons in the nucleus. So we can write an atomic symbol for this, or a nuclear symbol for this, Li, and we can place the atomic number in the lower left-hand corner. Now let's count the neutrons. Okay, there's 2 neutrons in this model, so the mass number is going to be the sum of those. 3 plus 2 is 5, so that's the mass number. We place that in the upper left-hand corner of the nuclear symbol. Now let's go ahead and count the electrons, right? 2 electrons. Let's use the charge formula here. Protons minus electrons is 3 minus 2, and that's equal to 1 on your calculator or in your mind. But in chemistry class, we always write +1. All right, if you have a charge of 4, you want to write +4 or -4. It's very important to put the sign of the charge. Where do we place that? We place the charge in the upper right-hand corner of the nuclear symbol, and we do not show a 1. If the charge is 1, we don't show the 1, we just show plus. So you can see how the number isn't too important. It's actually the sign that's even much, much more important, all right? So when you calculate the charge of +1, you only write plus in the upper right-hand corner. So this is a lithium plus or a lithium ion, all right? Here are other examples of ions that we're going to see in the class. We've got Na+. Okay, this sodium ion has a charge of +1. The 1 is not shown. We have oxygen, which is charged. Okay, so this is an anion, right? A negatively charged ion. And you could write the charge as -2 or 2-. You'll see this written both ways in various textbooks and lectures and so on online, okay? How about F-? F- is a charge of -1. There's not a 1 indicated there, but we do have the negative sign, okay? So that's an anion as well. Now we have this nickel, okay, Ni. Nickel could be +4 or 4+, however we write the charge. That's a +4 charged atom of nickel. It's an ion, it's a cation, okay? Cats have paws, cations have positive charge. All right, remember this picture here, probably from a video way back I made. This is sodium chloride, which is table salt. And the question here is how many protons and electrons are in Cl-? That's all we're given, Cl-. So you want to look, of course, on your periodic table and find Cl on the periodic table. I found it on the right-hand side. It's element number 17. From the 17, we can now calculate all that we need to calculate. We know that its atomic number is 17, so it has 17 protons, okay? Therefore, we can use the charge formula to plug things in, all right? Now, it's important to realize that the charge here is indicated by the Cl-. The charge is -1, okay? -1 is equal to 17 minus E. E stands for the number of electrons. I'm not going to do algebra here step by step to solve it. Just in our mind, we can think, oh, 17 minus 18 is going to be -1, and so that's how we figure out that there are 18 electrons. How about this guy here? This guy is crazy. We've got a nuclear symbol showing calcium. Its charge is +2 as indicated in the upper right-hand corner. Its atomic number is 20. Its mass number is 48. So we got numbers everywhere. From all of this information, we can very easily calculate the number of protons, neutrons, and electrons in this creature. First off, we don't really need to use the periodic table here because we have the atomic number 20. There are 20 protons here. Now remember that the number of neutrons is hidden in this figure. We use the mass number is equal to the protons plus the neutrons. And so the way to find this is very simply subtract the lower number from the top number. So 48 minus 20 is 28. It's kind of vertically oriented, so I kind of like that. And so we know now that this guy here has 28 neutrons. So we got 20 protons, 28 neutrons. Now we have to think about the charge. Once again, we have the charge indicated here in this nuclear symbol, +2, right? And that's equal to protons minus electrons. We know there are 20 protons. We don't know how many electrons there are. So just in your mind, think about this. 20 minus 20 would be 0. That's not right. 20 minus 22, oh, that's -2. So it'd be 20 minus 18. Yes, 20 minus 18 is +2. So the answer is going to be 18 electrons, okay? I'm not going to go over these practice problems for you. These are for you. But here's 4 problems on this page. Write the nuclear symbol for an ion containing 11 protons, 13 neutrons, and 10 electrons. You should know how to do this by now. How about this guy about magnesium? Okay. Number 3, we have indicate the charge for the symbol of a lithium +1, barium +2, and nitrogen -3 ion. So remember, the nuclear symbol is going to include the element symbol, right? So lithium would be Li, as we saw, and the +1 is indicated by a superscript to the right, plus. Okay, we don't write +1, we write just plus. So try to do barium +2 and nitrogen -3. How many protons and electrons are in Ag+? Another practice problem, just label these guys as cations, anions, or neutral atoms. So I'll leave those practice problems up to you to get you started in studying and gaining more chemical knowledge. Thanks for watching. Please like, please subscribe. Have a great day.